Oh, ah. Did I make mistakes? All right, are you ready? Okay. All right. Grace, are you ready? Still one more minute. One more minute. All right. So would you agree that f of -2 means the area accumulated from 0 to -2? That's got a whole ton of negativity going on. Because you're going from a greater number to a lesser, dt is negative. That's kooky. So me, the first thing I do anytime I have switch limits is I switch them back so they're going, quote unquote, the right way, at least in my mind. Okay, then I just do, okay, what's the signed area associated with that area? What is the signed area associated with that area? -2. And so, end result, those two negatives, the negative of going backwards combined with the negative y values actually makes a positive. Yeah? Pretty cool? Okay. This is going forward, so it's just straight up area, but only a quarter of a circle. So did you get 9 pi over 4? Okay? Any questions on it? Okay. B. F prime. You must make a connection of f prime to g. What is the connection of f prime to g? F prime is equal to g. Geometry just is reading that comes from taking the derivative of both sides of this idea. The derivative of this side is f prime. The derivative of the antiderivative is g. So f prime of 3 is g of 3. And g of 3 by the graph is 3. Okay? Yes? I didn't go, because I stopped here, I didn't get the full half circle. It was only a fourth of the circle. Yeah. If I'd gone to 6, it would have been 9 pi. Okay. C is F concave up or concave down at x equal 1. My thought process goes like this. To determine concavity, I need the, say it loud, second derivative, okay? F double is equivalent to what idea of G? You must connect to G. F double is the same as G prime, or the slope of the G graph, yeah? The slope of the G graph at x equal 1 is pi. positive. Here's 1. It's definitely positive there. And so from that reasoning, I would conclude that f is concave up at x equal 1. Check that you gave a subject, please. Don't just say concave up at x equal 1, because you have 2. Actually, you could say up to 6 ideas. So f, f prime, f double, g, g prime, g double. Tell me what's concave up, please. F is concave up at x equal 1. You with me? Okay, today's idea is out of order in my slides. Okay, so let's talk area between a curve and the x-axis. This is a pretty big idea of calculus, and it's actually several lessons. Then we'll get into volumes of three-dimensional figures. So this is just the tip of the iceberg. Okay, now, first of all, you need to start to differentiate between an integral with nothing attached to it and the question, find the area between the x-axis and x squared minus 2x on 0 to 3. It feels like, oh, isn't that the same thing? An integral means area under the curve, and they're describing the words, area between the x-axis and x squared minus 2x. Now, this actually, an integral with no further stipulations is sine area, or if you like, net area. This, the area between the x-axis, that's going back to more the geometric idea of you don't have negative area. Area is positive, period. Okay? This is geometric area, positive only, not sine. And you could think of this more as total area, not net area, not positive area take away negative area. It's just total area without respect to the sign of that area, all right? Now, if you were to then visualize this curve, y equals x squared minus 2x is the same as x times x minus 2, which helps us graph it a little better. It's a parabola with zeros at 0 and 2. And opening up. And 0 to 3 would be talking about that shaded region. You follow? Now, in terms of the two questions, though, the two questions would be looking for two different things. The integral from 0 to 3 is the net area. So it would be like the positive area take away the negative area, and it would be more something small, I would imagine. If those areas are fairly close to each other, then it'd probably be close to 0. But the area enclosed would be make both areas positive and add to get total area. They're a little different. And now, because they're a little different, you can't just mindlessly slap an integral at the second question. You have to make some adaptations. Now, if the area question is asked, I would approach that two totally different ways on whether if I had my calculator or not. If I had my calculator, I want to make the negative area positive, so I'm not getting sign error. How do I remove the sign from a function? What does that? What removes the sign from a function? Makes it always positive. That's absolute value, okay? To make a negative area positive, I want to remove the sign, and I could use the absolute value. So I could get the total area by taking the integral from 0 to 3 of the absolute value of x squared minus 2x. Now, what the calculator is going to do then is it's actually going to say, oh, you want me to find this area. It's going to take those negative y values, make them positive, and then calculate the area, and I'm going to get a total area rather than net because it's all positive y's, yeah? So if you do that in your calculator, then you're going to go the old shift plus to get the integral, 0 to 3. And the absolute value function, I typically go in this catalog function next to the 9. Give me a second. Who did that? No, there. There's also calculators in the back if you need one. Absolute value is in that submenu right there. If you have 84, let me know, and I can also help you there. Did I choose that? Okay, so x squared minus 2x, I believe the function was. Squared minus 2x. You do have to say what you're integrating with respect to. And you got 2 2/3, or 8/3, yeah? Okay, easy enough. This is 8/3. Now, if you were going to do this without your calculator, then, as you might expect, it's a little more work, all right? You're not going to use this absolute value idea because we haven't talked about how to integrate absolute value. What you are going to do, basically the idea at the heart of it, instead, you use two integrals and you switch the sign / negate of any negative function region. So my setup might be something like this. The total area would be the integral from 0 to 2. Instead of going normal x squared minus 2x, which is below the axis, I want to take the opposite of x squared minus 2x. Now you could take that negative inside, you could put it outside, doesn't matter. But you definitely need to negate that so that you can achieve basically this idea. Take the region below and make it region above. Then you're going to add the region from 2 to 3. Now 2 to 3, I don't need to do anything to that because it was already positive, so I'm going to leave it alone. And go from there. You follow? If I do that, then what is the antiderivative of negative x squared? Negative x cubed over 3. And what's the antiderivative of positive 2x? So you agree that'd be a history. So x squared. From 0 to 2, I'll do that in a second. And then the antiderivative here is 1/3 x cubed minus x squared. This should be 2 to 3, yes? Sorry, not 3 to 3, that's not 3 to 3. Okay? All right. So if I go, it's negative 8/3 plus 4 minus zeros plus 27/3. Yes, I understand that reduces. Minus 9 minus 8/3 minus 4. You agree with my fundamental theorem work? Okay? The total on all the thirds, I have 27/3 minus 16/3. Do you agree? 27/3, and I'm subtracting away to 8/3, so that's 27/3 minus 18/3, which is 9/3. And I have 4, oh, that's a problem here. That's not what I would expect. Did I make a mistake here? This is not going to come out 8/3, I can tell you right now, but let's see how, let's just figure out where my error is. 4, and what about the total on the positives? 4 plus 4 is, oh yeah, no, it's not coming out anymore. So I get a total of 8 minus 9, or minus 1, yeah? Now that's 2, and that's wrong. So what's going on here? You see where I made an error?
27 minus 16.
Oh yeah, 27 minus 16, not minus 18. Thank you. That's better. Okay, this is not a 9/3. 27 thirds minus 16 thirds is 11 thirds. Thank you very much. Okay, are we down? So 11 thirds minus 1 is 11 thirds minus 3 thirds, which is 8 thirds. That's okay. You follow? All right. Now let's talk about area between a curve and the x-axis where the curve is kind of ugly. It doesn't have such nice, clean, pretty princess zeros. So first thing you do is pick up the old calculator and graph the function. So, okay, so something like x to the third minus 5x squared plus x plus 1, boom. Okay, it says find the area enclosed by the cube and the x-axis. Now that's the total area, geometrically speaking. So I want the sum of this area here and that area. Now obviously I have a problem because would it work to just slap an integral from there to there? Would that give me total area or signed area? That would give me signed area. It'd probably be negative because I've got a heck of a lot more negative area. Do you agree? So how do we use our calculator to make all regions positive? Absolute value. So we're definitely going to do this. Okay? The only question at hand is the limits of integration. How do I get them? Find the zeros. All 3 zeros? Which zeros? Do I need that interior zero? Not really for this problem. All I need is the total region that's enclosed, so the left endpoint to the right endpoint. So you should find the zeros and store them. Oh, shoot. And the first one I get something like 0.604. How about you? Okay, you always definitely want to store these and record them to 3 decimals. Though you're going to use the stored values. Do you agree with this stored, my first 0.604? Oh, I didn't. Darn it. You should say, no, I don't agree because I found the interior one. Good call. Sorry. Okay, do you agree with negative 0.348? All right, there we go. Let's do that. Shoot, I guess I'll call it B, never mind. So, you would record that, negative 0.348, find the upper zero. And 4.744? Yes? Okay. 4.744. You should always record 3 decimals in your work, not just your final answer. And now you can have the calculator do the heavy lifting of calculating tons of rectangles. The calculator is actually going to now calculate the area of thousands of rectangles and give you a numerical approximation. So if you go from, I called mine B and C, but whatever you called them, all those limits up, slap some absolute value on your function. Holy Jimmy. I've got a lot of stuff going on there. Oops, that's not what I want. Okay, and I'm getting something like 36.4406. How about you? Okay? So they would take 440 or 441 or more. If you are asked to give an expression of two integrals that could also find the total area, then how would you go about that? How would this area be found with two integrals? And I'm going with the assumption of no absolute value. From negative 0.348 to, oh, dang it, hey, see, I did need that one. I was so smart, I was thinking ahead. That interior zero is 0.604, okay? So talk to me. The first region, this region here, from 0.348 to 0.604 of f of x. Add to that, or if you like, or actually add to that the region here. How are you going to find that region? From 0.604 to 4.744 of negative f of x. Negative f of x. Because that region was below the axis, use the opposite of f of x. That would achieve the same idea, making all negative y regions positive y regions. The absolute value and the switched f accomplish the same thing. You with me? Okay. Let's go to the next idea. If you're working without a calculator, that's really where you're going to expect a lot of grunt work in terms of getting the area. This is asked on the no calculator part of the AP exam. It's a pretty common question. You need to practice it. It's basically you're practicing the skill of doing the arithmetic without screwing it up. So, would you tell me what you know about the graph of f here? Perfect. Thank you. And it is a cube, positive cube shape with that, yeah? Okay, cool. So, if I want to find the total area enclosed by no calculator, then the absolute value is out the door. And instead, I'm going to go two integrals. The first integral will be from where to where? Negative 2 to 0. And will I use normal f or negated f? Normal f. It might help to actually have this multiplied out. X squared plus x minus 2. So I'm feeling x cubed plus x squared minus 2x is the function. Correct me if I made a mistake. I feel like it's good. Okay, so I would use normal f there. This is squared, right? Okay, and then in the next region, from where to where? 0 to 1, and the opposite of all. So negative x cubed minus x squared plus 2x. Wait. All right, now we're in for some grunt work. Like I said, the antiderivative is x to the 4th over 4 plus x to the 3rd over 3 minus x squared from negative 2 to 0. Then negative x to the 4th over 4 minus x to the 3rd over 3 plus x squared from 0 to 1. Yeah. All right. My first result would be a GABA zeros. Be careful with your parentheses. Distribute the negative associated with the fundamental theorem. So I would get something like 16 fourths minus 8 thirds minus 4. You will find that I rarely reduce. This just goes to how it was taught, Bill and Mrs. Walker. If you don't reduce them, you'll always have common denominators built in, and you can always reduce them. So I just don't reduce. If you go 1, you have negative 1/4 minus 1/3 plus 1 minus a bunch of zeros. Cool. In terms of the fourth total, negative 16/4 minus 1/4 is negative 17/4. 8/3 minus 1/3 is 7/3. And 4 plus 1 is 5. Again, correct me if I made a mistake or if you feel different. Common denominator is 12. The first times 3 is negative 51. The second times 4 is 28. And 5 times 12 is 60. Altogether, 88 positive minus 51 is 37. Total area is 37. Okay? Okay. The hardest problems by far are problems where you have zero idea what the graph is. Flying blind, you could say. Okay? If I say find the area enclosed by the x-axis in that curve on 0 to 4, no calculus, then you need to get a feel for where was f positive and negative so that you can deal with that negative area situation and positive area situation. And so the first thing I would do is sign test f. Not f prime. I'm not finding extreme. It's not a derivative test. I'm finding just what does the graph look like? When is it above and below the axis? Let's start by finding zeros. Where is 3x to the half minus 2x to the 3 halves equal to 0? How would you tackle the algebra? Do you? What is your? You just have x to the half and x to the 3 half? Okay, thank you. Okay? Am I good? Okay, how would you do that? Is factor out of greatest common factors a good way to go? What could you take out? You might even think of this way. This is how I picture this. Does that help? Okay, what's greatest common factor? You can take out a square root of x. What's left? 1 minus just x. Okay. Then zeros are 0 and 1. Okay. Now in terms of signage, negative 1, or sorry, not negative 1, that's 0. 0, 1, and 4. I'm stopping it on 0 to 4, right? They only said look in this interval, yeah? So from 0 to 1, positive or negative, like at 1/2. Positive. And from 1 to 4, negative. Okay? So if I want to find the total area under the curve, this has positive y values, so it's above the axis. I don't need to do anything to that. My first integral can be from 0 to 1 of x to the half minus x to the 3 halves. But the next region is below the axis, as indicated by the sign chart, so I need to switch the signs. So take the opposite of that. I might integrate x to the 3 halves minus x to the 1 half. Checkity check. All right, now we're rolling. What's the antiderivative of x to the half? X to the 3 halves and 2/3 out front. What's the antiderivative of x to the 3 halves? It's x to the 5 halves from 0 to 1. I'll tackle that in a second. The antiderivative of x to the 3 halves is the same. 2 fixes x to the 5 halves, 2/3 x to the 3 halves. 4, yay? Okay, this at 1 is 2/3 minus 2/5 minus 0. You will never see me write nothing for 0. It's temptation for students to say, oh, 0, I can float. No, you should never just assume that when 0 goes in, it's not anything, because there are a lot of functions that when you put 0 in, you get something. So this, always take the time to evaluate it, even at 0, because e to the x at 0 is not nothing. Cosine of x at 0 is not nothing. Okay, so don't assume that 0 is nothing. That's bad technique. Plus 2/5 to the, or times rather, 4 to the 5 halves. What's 4 to the 1 half? 2 to the 5th. 32. Okay, minus 2/3. 4 to the 3 halves. 4 to the 1 half is 2, to the 3rd is 8. Minus 2/5 minus 2/3 with 1/5. Stop me if you disagree. Okay, so altogether I have, in terms of thirds, I have 2/3 minus 16/3 plus 2/3. That's 2/3. 2/3 plus 2/3 is 4/3. What's 4/3 minus 16/3? Negative 12/3. In terms of the fifths, I have negative 2/5, 64/5, minus 2/5. So 64/5 minus 4/5 is 60/5. Do you agree? All right. That's negative 4 plus 12. Your answer is 8. Okay? That is as bad as you're going to get. Do I have extra practice for you?
Yeah, you do.
I think I was going to do extra practice.
No, you told me that we weren't gonna have a set.
Did I say that?
Yes.
Oh, well, I might have to change that tomorrow. I'll see how it's going. All right, questions on sets. What do you got? 58 still? 57 still? 57. And 58 if we have time. What do you got on 57? 1 and 5. Did I hear that right? 1 and 5?
Yes.
Yay. 1, 5, 20.
21.
4?
8.
Okay. Let me know if you have it on it. Okay. Okie dokie. The idea of this problem is that there are many rectangles I could draw that are squeezed in between the line and the axis. All of them have different areas. What's the greatest possible area? So, we want to maximize the area of the rectangle. Then you say, what's an equation for the area of the rectangle? X, y. Then you substitute to get it down to 2 variables. How do you do that? Okay, yeah. The x and the y are always related by being points on the line, yeah? They're not x, y in here somewhere. That's stupid. That would be a very big rectangle if I put x, y there. Do you agree? So to really get out to the boundary, I'd have to be on the line. Therefore, x and y have to be related by being on the line. What's the equation for the line? Y equals mx plus b. Sounds good. That work makes sense in this case because you do have the b of 6, yeah? I'm with you. What's the slope? Negative 3 halves. Yeah, down 6 over 4, so negative 3 halves. I am with you 100%. So if that goes in there, then you get maybe, I'm going to throw it in and distribute if you don't mind. Negative 3 halves x squared plus 6x. Does that get you going? How will you proceed calculus-wise to find the max? Max if what happens? Derivative goes positive to negative. So you take the derivative, which should be an easy derivative to take. The algebra is easy. You should be with me?
Yes.
Okay. 5. Is 5 still a question? 5, I kind of lied to you when I said no calculator because the quadratic you get is garbage. So let me stipulate that you can use your calculator to solve the quadratic, but not to find the max. Fair enough? Does that help, or should I still do the problem? Still do it, okay. So the idea is that the original, you have a sheet of aluminum that is 0.3 on each edge, square. That's actually pretty good. You're going to cut out little squares and fold that shape up to make a rectangular prism. Now when you do that, if how big you're cutting out is unknown, then you're going to cut out an x size square from each side. What will this dimension be if it started off as 0.3 and you cut off x from each side? 3 minus 2x. By the same kind of thought process on the other side. And how high is the prism? Or how tall? It's x. Okay? So the volume is 0.3 minus 2x squared times x. Now we want to find the maximum volume, so v prime positive to negative. Distribute it out or use the product rule? Use the product rule, okay? I like it. First stays the same. 0.3 minus 2x squared times the derivative of the second is 1, plus second stays the same. X times the derivative of the first. What's the derivative of the first? Be careful to use the chain rule properly. 2 comes down. The inside stays the same. Drop it to the first, but then multiply by the derivative of the inside, which is -2. Maybe I should have used that. I don't think I used the product rule on my key. Maybe I should have done that. There's a common factor built in that's beautiful. I can take a 0.3 minus 2x out, yeah? When I do, what's left here is a single 0.3 minus 2x. And what's left here is a negative 4x. Correct me if I'm wrong. Are we cool? We don't need a calculator for this. What the heck? 0.3 minus 6x then. This is going to have critical numbers where the derivative is 0 or undefined. So 0.3 minus 2x is 0. Then x would have to be 0.3 over 2 or 0.15. Okay? If 0.3 minus 6x equals 0, then x would have to be 0.3 divided by 6, or 3 divided by 60, or 1/20th, or 0.05. You follow? Okay. In terms of the shape of this sign chart, v prime, 0.5 to 0.15. I feel like this would be positive, negative, positive on my sign chart. It would be the other way around.
Why is it 0?
Did I say, oh, 0.05, sorry. Gotcha. Yes, you're right. Okay. So, where's the max? At 0.05 or 0.15? 0.05. That's the max. Max if the cut size is 0.05. I think the units are centimeters. And if they wanted the volume, you could plug that into the volume. Are we cool? 25. Is 25 still a question? Yeah, this was really hard to get started. Good question. Find a positive number that exceeds its cube by the greatest amount. Positive number that exceeds its cube by the greatest amount. Right away, it kind of cooped me out that you're talking a cube, a number exceeding its cube. Isn't a cube usually greater? So what kind of numbers is a number greater than its cube? That's pretty weird. Okay, so negatives, so you're right to automatically think, all right, it's got to be some kind of funky numbers. When you think, how do numbers behave differently? Negatives obviously behave different than positives. 0 behaves different than everything. And numbers between 0 and 1 behave differently than numbers after 1. Now, they did say a positive number, so I'm going to throw negatives out, although that's a logical thing to go. Anything that would exceed its cube, that only happens when you're talking a number between 0 and 1. Because when you cube a number that's between 0 and 1, it doesn't make it smaller. Right? So I know right away it's got to be something between 0 and 1. That's the only way it's going to exceed its cube. But I still don't know what the heck to do. Do we know the number? We don't. So let's call it x. Okay? Exceeds its cube. What's its cube? X cubed. And we want to know the greatest amount it exceeds. So we want to know the greatest. Exceeds is the difference between the two. Yeah? And so don't we want to find the max difference between the two? That should then get you started. D prime is 1 minus 3x squared. You could find the critical numbers. And I can, okay, you want to find where D prime goes positive to negative for max. Okay. 21. Question on 21. Does anybody need 21, or you're still finishing that one? Hold on a minute. Okay. Let me know when you go. Okay, so does somebody really need 21 still? I don't want to waste time. Yes? Okay. Normal line process is a lot like tangent line process, just one small difference. The point is the same. You still calculate the point I'm getting. The point is 2, 1. The slope, you still start the same. You still need the derivative for the tangent slope. By quotient rule, low d high. The derivative of root x plus 2 is 1 over 2 root x plus 2 times derivative inside is 1. Minus high below, which is 1, over the square of what's below, okay? I could clean that up, but let's just find that slope at 2. What do you say? So if I plug in, I have 2 times 1 over 2 root 4 minus root 4 all over 4. That feels like 1/2 minus 2 over 4, which is negative 3/2 over 4, which is negative 3/2 times a fourth, which is negative 3. Okay, so the tangent slope is negative 3/8. If the tangent slope is negative 3/8, then the normal slope is perpendicular, and so it is 8/3. Then point slope formula, y minus 1 equals 8/3 x minus 2. Okay. Tangent slope and perpendicular. All right, 4. Is 4 still a question? All right. 4. 4. Okay, a particle, this is in Calc 2, you do parametric equations in motion in 2 dimensions, or rectilinear motion. It's moving along this guy, and as it passes through 4, 3, the y-coordinate is decreasing at a rate of 3 units per second. That right there tells me what direction.
Good morning, Devlin Jaguar. Please rise for the Pledge of Allegiance. Please begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Boys mentoring will meet tomorrow. Please report to your assigned room for attendance and directions for today's activities. See Mr. Northway if you have a conflict.
Devlin and travelers, we will have our first meeting tomorrow during Hill Tower. Please sign up with either Mr. Parsons or Mrs. Hall. Meet in Mr. Parsons' room, West 211. See you there.
Come to the library to vote for the prestigious Colorado Blues Group Book Award.
Differentiate well with
This book
respect to
award
time.
is so significant because the winner is chosen only by kids, no adults allowed. Let your choices and voices be known. Vote now.
Check that you have a 0 on the right.
Make sure a final care package has been ordered for you. They can be ordered until Friday,
2,
November 30th.
4.
Purchase on the Jet Cookies website or at the financial office. Don't miss out on this fun tradition and important school fundraiser.
Wait, is it free?
All fall athletes that have had a big locker and are not in a winter sport need to clean your locker and return your locks to Mr. Perico and Miss Natalia today. Please take care of this
0 X
and
and Y
safety.
DYDT.
Senior high students. High school students interested in working on the stage group for this year's musical, there will be a meeting today after school. We will be meeting in the drama room. All students are welcome and no experience is required. Come build a set and be a part of the production.
That makes sense.
The deadline for early applications to University of Colorado at Boulder is today. Get those applications completed and requested your transcript if you need to. And remember, they do require teacher recommendations.
There are only 2 more days for the Spanish Honors Society Can Do
8.
That. Currently, Miss Beaton's 3rd hour class is leading
When's the last day for
110
cans?
cans. In second is Mrs. LeBlanc's 3rd period class
8.
with 59.
Is 8
And
still
in
here?
third, Mrs. Ford's 3rd period class with 57.
It's
Tomorrow
yes.
is the last day. That's all your announcements. Have a great day.
Okay, so the work, it might just be the work I expect, and I would expect something like this. You take that expression and rework it, showing the integral rules you're using. So this, at minimum, I don't mind if you're a little slack with the differentials, although I do it all the time. It's not very good calculus, but then use the values they give you. They give you the value for f, which is -2, and they give you the value for g, which is 4. So 6 plus 8. Okay? That's the work I want. Alrighty, how about a question on, actually maybe you can at least get started on this guy. How did the UPS problem go? Okay, in order to get you started, maybe I can start here. This is what you would call a rate in, rate out kind of problem. Okay, and it has the fundamental theorem in it because you have to sum many rate calculations. So area under a rate curve gives the amount of change. The problem is as 2 rates, a rate in and a rate out. If you think of then the total rate of change in the number of packages, it combines these 2. This is how packages arise. So this is a positive because it's adding packages. So P of T, that is the rate at which they enter. Take away the rate at which they leave. The rate at which they leave, they process packages at a fairly constant rate of 750 packages per All said then, you could say the net rate of change in the number of packages, if you took that, take away that, it would be something like 250 plus 420 sine pi over 5 times t minus 2. Let me tell you, it's not easy to write a model like this, by the way. Graph function over the time on the sheet. That'll get you started. Okay? Have a lovely day. Stay out of trouble.